Good morning, everyone. Yes, very good morning to all of you. Let me wait for a couple of minutes so that let all the other members also join. Okay. Till then, you make sure that you have solved all the earlier problems. Okay. Please wait for a couple of minutes. Okay, students, if you have any doubts from yesterday's class, we can ask me. One student has asked me to solve question number 48. So let me check where is question number 48. Okay. Forty-eighth question. The question is, limit extends to 0. E power 2x minus 1 divided by 3x. If you directly apply the limit, you are going to get 0 by 0, an indeterminate form, right? So I'll use L'Hospital's rule. If I use L'Hospital's rule, I will get derivative e power 2x is e power 2x into 2 divided by 3x is there. First derivative is 3. Apply the limit as extends to 0. E power 0 is 1. 1 into 2 is 2. 2 divided by 3. So 2 by 3 is the answer. Okay. Am I audible? Can you hear me? Students? Yes. Yes. Okay. Fine. Still the number of participants is very less. Yes, I have muted everyone. Okay. Thirty-fourth question you want me to solve? Okay, just a minute. 34th question. Let me solve 34th question before everybody else joins. What is that 34th question? Let me check. Limit extends to 0. Root cos x minus cube root of cos x divided by sine square x. Okay, we have to evaluate this limit. Here, if I directly apply the limit cos 0, 1, here Cos 0 is 1. Cube root of 1 is also 1. 1 minus 1, 0. Denominator sin square 0. That is also 0. So I will use L Hospital's rule. Before that, I will write, okay, this root cos x, let it be as it is. And this can be written as cos x to the power 1 by 3. Right? Cube root of cos x divided by sin square x. Now use L Hospital's rule, which means we are differentiating. Derivative of root cos x is 1 by 2 root cos x into minus sin x minus the derivative of cos x to the power 1 by 3, that is 1 by 3 into cos x to the power 1 by 3 minus 1, which is minus 2 by 3 into minus sin x divided by the derivative of sin square x, which is 2 sin x into cos x. Now take sin x as a common factor here and cancel that sin x. Once you cancel sin x, then we are left with the minus 1 by 2 root cos x minus into minus plus 1 by 3 into cos x to the power minus 2 by 3. That sin x we have cancelled divided by 2 cos x. Now apply the limit as x tends to 0. When x approaches 0, cos 0 is 1. So here minus 1 by 2 we get, plus here 1 by 3. Cos 0 is 1. 1 power minus 2 by 3 will be 1 only. 1 by 3 into 1 will give you 1 by 3 divided by 2. Take LCM here. 6 is the LCM. So this will be minus 3 plus 2 divided by 2. Minus 1 by 6, which means minus 1 by 12 is the answer. Minus 1 by 12, which is the fourth option. Okay, now the students have joined. Let's start today's class, lecture 4. Okay. Hello, I welcome you all for today's maths class. Good morning, everyone. Let's continue our discussion on limits. See, to get a good grip over limits, you need, not just in limits, in every case, you have to solve a lot and lots of problems. Okay, then only, if you solve varieties of problems, then you'll get a good grip over the subject. So solve all this. See, yesterday's assignment questions, if you had solved, then understanding the topics which I'm going to teach will be easy for you. Whatever the problems that I teach now today, you can understand them better if you had solved the earlier problems. Okay, so again, similarly, when we go to level 2, if you are thorough with level 1, then understanding level 2 problems will be easy. Okay, so now let us start our class today. 54th question, limit extends to a log x minus log a divided by tan x minus a. If I directly apply the limit, I'm going to get log a minus log a, that is 0, divided by tan of x minus a. Then in place of x, if I substitute a minus a, it will be 0. Tan 0 is 0. So 0 by 0. So when I think of, when I come across 0 by 0, immediately I'll think of L Hospital's rule. Okay. Differentiate it. Derivative of log x is 1 by x. Derivative of log a is 0 because it's a constant. Divided by tan x minus a is there, whose derivative is secant square x minus a. Okay. Apply the limit. Put x is equal to a. We get 1 by a divided by secant square 0. Secant square 0 is 1. So the answer is 1 by a. 1 by a, which is the first option. Okay. Next question. 56th question. Limit extends to 0 log 1 plus x to the base e divided by 3 power x minus 1. Limit extends to 0 log 1 plus x to the base a divided by 3 power x minus 1 is equal. Apply the limit as x tends to 0. We get log 1 plus 0. That means log 1 you get. The value of log 1 is 0. Numerator will be 0. Denominator. Here in the denominator, if I put x as 0, 3 power 0 will give you 1. 1 minus 1, that will be 0. So denominator is also 0. Numerator 0, denominator also 0. 0 by 0 is an indeterminate form. So I will use L Hospital's rule. Okay. So derivative of log 1 plus x is 1 by 1 plus x. divided by the derivative of 3 power x minus 1. That is 3 power x into log 3. Okay. Apply the limit now. As x tends to 0, this will give you 1 by 1, that is 1, divided by 3 power 0, which is 1. So denominator is log 3. 1 into log 3 will give you log 3. Okay. But this option is not there. I can write this here. The base is not mentioned, so it is obvious that the base is e. Log 3 to the base e. When I take it to numerator, it will become log e to the base 3. Because you know this formula, log a to the base b is nothing but 1 by log b to the base a. Okay. So 1 by log 3 to the base e can be written as log e to the base 3, which means fourth option is the right answer. Okay. Then 58th question. Limit n tends to infinity 1 plus 3 plus 5 up to 2n minus 1. 1 plus 3 plus 5 up to 2n minus 1 divided by, in the denominator, we have 2 plus 4 plus 6 plus etc. up to 2n. Okay. So now 1 plus 3 plus 5 up to 2n minus 1. That is nothing but sum of the first n odd natural numbers. Sum of the first n odd natural numbers is equal to n square. Is equal to n square. In the denominator, I will take 2 into 1 plus 2 plus 3 up to n. Okay. So now many of you may be thinking, sir, how do we know that 1 plus 3 plus 5 up to 2n minus 1? Sum of the first n natural numbers is equal to n square. Some of you may be having that doubt. Let me clarify. How did I get that? Say 1 plus 3 plus 5, etc. This is in AP with the first term 1 and common difference 2. So sum to n terms of an AP is equal to n by 2 into a plus l. You can do n by 2 into a plus l. A plus l means 1 plus that l. L is the last term. 2n minus 1. 1 gets cancelled. So we get n by 2 into 2n. 2 gets cancelled. It is equal to n square. N into n will give you n square. Okay. So denominator, what did I do? I have taken 2 as a common factor. So if I take 2 as common factor, then you have 2 into 1 plus 2 plus 3 up to n. Okay. That's equal to limit n tends to infinity n square divided by 2 into. Now this 1 plus 2 plus 3 up to n is nothing but n into n plus 1 by 2. N into n plus 1 by 2. Right? 1 plus 2 plus 3 up to n is equal to n into n plus 1 by 2. Here 2 gets cancelled. So we have limit n tends to infinity n square. Denominator n into n plus 1. If I take it inside, it will become n square plus n. Okay. Now we observe both numerator and denominators are polynomials of the same degree. Okay. So when you have numerator and denominator, both polynomials of the same degree, and then as n tends to infinity, the value of this limit, when both are of the same degree, then the value of this limit is equal to coefficient of highest power of x in the numerator divided by coefficient of highest power of x in the denominator. You recall this? Limit x tends to infinity f of x by g of x. Both f and g are polynomial functions of the same degree. If they are polynomial functions of the same degree, then this is equal to coefficient of, so let us say this is a polynomial of degree n and this is a polynomial of degree m. Now n is equal to m. Then this will be coefficient of x power n in the numerator divided by coefficient of x power n in denominator. I had explained this earlier in my first class of limits. Okay. So now here the coefficient of n square is 1. Denominator also a coefficient of n square is 1. 1 by n, that is 1 by 1, that is equal to 1. Okay. So did you understand this problem? Students, any doubt about this? No. Okay, fine. Clear. Okay, let's have a look at the next question, which is 59th question. Limit n tends to infinity, 1 plus 1 by 2 plus 1 by 4, etc. up to 1 by 2 power n divided by 1 plus 1 by 3 plus 1 by 9, etc. till 1 by 3 power n. Look at the numerator. You have 1 plus 1 by 2 plus 1 by 4, 1 by 4 plus, etc. till 1 by 2 power n. So numerator is in GP, right? It is in geometric progression with the first term 1 and common ratio 1 by 2. Similarly, denominator, observe the denominator. We have 1 plus 1 by 3 plus 1 by 9, etc. till 1 by 3 power n. Denominator is also in GP with the first term 1 and common ratio 1 by 3. Okay. So denominator is in GP with first term 1 and common ratio 1 by 3. Now sum to n terms of an AP of a GP. Sn, you know the formula. Sn is equal to A into R power n minus 1 by R minus 1 if R is greater than 1. In this case, both numerator and denominator R is less than 1. So A into 1 minus R power n divided by 1 minus R. Okay. So now, if I use that formula here in the numerator, A is 1 into 1 minus R power n, 1 by 2 to the power n divided by 1 minus R, that is 1 minus 1 by 2. Then in the denominator, A is 1 into 1 minus R power n, that is 1 by 3 whole power n divided by 1 minus R, which is 1 minus 1 by 3. Okay, then that's equal to limit n tends to infinity. See, as n tends to infinity, 1 by 2 whole power n will become 0. Limit n tends to infinity, 1 by 2 whole power n will be equal to 0. How it will be equal to 0? You just observe 1 by 2 whole power n. I'll go on increasing the value of n. Then let us see what happens to the value of that fraction. If I put n equal to 1, then I have 1 by 2. Put n equal to 2, 1 by 4. Observe 1 by 2 is greater than 1 by 4. Put n equal to 3, you get 1 by 8. Then you get 1 by 16. Go on increasing the value. Put n is equal to 10. When I put n is equal to 10, I'm talking about 1 by 1024. Now you imagine n is tending to infinity. So observe 1 by 2 is greater than 1 by 4, that is greater than 1 by 8, greater than 1 by 16, 1 by 32, 1 by 64, etc. So when you go on increasing the value of n, the value, the denominator becomes larger and larger. Numerator is 1 only. Denominator becomes larger and larger and the numerator is 1 only. So as the denominator increases, the value of the fraction goes on decreasing. And by the time this n reaches infinity, this fraction will reach 0. Okay, by the time n reaches infinity, by the time the power reaches infinity, the value of this fraction becomes 0. Now, so I will write like this. Suppose you have a limit n tends to infinity, p by q whole power n, where p by q is some number. Okay, so p and q are some integers. I will take, of course, q not equal to 0. Now, if p by q is greater than 1, if this fraction is greater than 1, for example, I will take p is equal to 2 and q is equal to 1. Then I'm talking about limit n tends to infinity 2 power n. Now, if I go on increasing the value of n, the value of this fraction, this expression will also increase. 2 power 1 is 2, then 2 square is 4, 8, 16, 32, 64, 128, etc. 1024, 2048, 4096, and so on. So the value of this fraction goes on increasing. And by the time n reaches infinity, this will also become infinity. So limit n tends to infinity, p by q whole power n. I can say this is equal to, I'll write here. p by q whole power n is equal to infinity if p by q is greater than 1. If that fraction is greater than 1, then this tends to infinity. And if that fraction is less than 1, then the answer will be 0. If p by q is less than 1. If p by q is less than 1, then as I said earlier, you can take a look at that example, 1 by 2 whole power n. So 1 by 2 whole power n, if I go on increasing the value of n there, then that by the time n reaches infinity, 1 by 2 whole power n will reach 0. Okay. And suppose if p by q is equal to 1, then you're talking about 1 power infinity. 1 power infinity is an indeterminate form. How to evaluate that limit, I shall explain afterwards, maybe after a couple of classes. When we come across such problems, I'll explain. So now you just remember that any fraction, okay, so p by q, one fraction is there, power is n. If you take that power to infinity, the value of that fraction will become infinity if that fraction is greater than 1. And that value of that fraction will become 0 if that fraction is less than 1. Okay. So therefore, 1 by 2 being less than 1, whole power n, 1 by 2 whole power n, as n tends to infinity, will become 0. Similarly, 1 by 3, that is also less than 1. So 1 by 3 whole power n, that will also become 0 when n tends to infinity. Okay. So that will give you here, this 1 by 2 whole power n will become 0, 1 by 3 whole power n will also 0. 1 divided by 1 minus 1 by 2, which is 1 by 2, whole divided by, this will be 1 divided by 1 minus 1 by 3, which is 2 by 3. So that's equal to, this is after applying the limit. That is equal to, here it will be 2, here it will be 3 by 2. So the answer will be equal to 4 by 3. If numerator is greater than denominator, that is what I'm saying. If numerator is greater than denominator, that means the fraction will be greater than 1. Say numerator is greater than denominator. For example, 3 by 2 whole power n. Now if you go on increasing the value of n, the value of the fraction goes on increasing. 3 by 2, if you put n equal to 1, 3 by 2. If you put n equal to 2, 3 by 2 means 1.5. If you put n is equal to 2, we are talking about 3 by 2 whole square, which means 9 by 4, which is more than 2. 8 by 4 is 2, so 9 by 4 is 2.25 you get. Okay. So then if you put n is equal to 3, we are talking about 27 by 8, which is greater than 3. Okay. If it is 24 by 3, 24 by 8, which is 3. So 27 by 8 means 3 point something like that. Okay. So now this fraction, as the power n tends to infinity, the value of this expression will become infinity. Okay. So with the increase in the value of the power, the value of that fraction goes on increasing. Therefore, when the power reaches infinity, the fraction will also reach infinity. Okay. Is it clear? This problem, did you understand this concept especially? Limit n tends to infinity, p by q whole power n is infinity if p by q is less than 1, and 0 if p by q is, sorry, p by infinity if p by q is greater than 1, and 0 if p by q is less than 1. Okay, so look at the options. We have 4 by 3, 3 by 4, 1 by 2, and 0. So our correct answer is 4 by 3, which is the first option. Okay, once again, you want me to explain. Look at the numerator, 1 plus 1 by 2 plus 1 by 4, etc. up to 1 by 2 power n. So it is in GP. Sum to n terms of a GP is given by a into 1 minus r power n divided by 1 minus r. That is a formula, you know. So that formula is here, a into 1 minus r power n by 1 minus r. Here in the numerator, a is 1, first term is 1. R, the common ratio, is 1 by 2. So a into 1 minus r power n, 1 minus 1 by 2 whole power n, divided by 1 minus 1 by 2, 1 minus r, that means 1 minus 1 by 2, divided by a into, a is 1, into 1 minus r power n, 1 minus 1 by 3 whole power n, divided by 1 minus r, means 1 minus 1 by 3. Now as power tends to infinity, the value of this fraction, 1 by 2 whole fraction, 1 by 2 whole power n, when the power tends to infinity, this fraction becomes 0. Okay. So similarly, 1 by 3 whole power n will also become 0. Then simplification will give you 4 by 3. This is one way of solving this problem. There is another way also. Okay, that is, see here, I can write like this. Limit n tends to infinity Sn is equal to S infinity. Limit n tends to infinity as n tends to infinity, Sn is equal to S infinity. Limit n tends to infinity, Sn is S infinity. So for S infinity of a GP, you have another formula, that is A by 1 minus R. Directly you can use that formula also for this problem. S infinity we want. So in the numerator we have 1 plus 1 by 2 plus 1 by 4, etc. Here A by 1 minus R means 1 by 1 minus 1 by 2. Denominator we have 1 plus 1 by 3 plus 1 by 9 and so on. So A by 1 minus R. Okay. So this on simplification will give you 4 by 3. In this way you will get the answer quickly. Okay. See, both are one and the same only. Here what we did is we found the sum to n terms and then we took that n to infinity. Whereas now in this method what we are doing is, instead of finding sum to n terms directly, we are going for sum up to infinity. Okay. Next, look at 61st question. Limit n tends to infinity 3 to the power n plus 1 plus 2 to the power n plus 2 divided by 3 power n minus 1 plus 2 power n minus 2 is equal to. So if I directly apply the limit, I am going to get infinity by infinity now, because 3 power n plus 1. If I take this power to infinity, 3 power infinity, 3 is a fraction which is greater than 1. So this will be infinity, this will also be infinity, this is infinity, this is also infinity. So what I do is, I can write 3 power n plus 1 as 3 power n into 3, right? 2 power n plus 2 as 2 power n into 4 into 2 square, that will be 4. Similarly, here 3 power n minus 1 is there. So that will become 3 power n into 3 power minus 1, which is nothing but 1 by 3. Plus, here 2 power n into 1 by 2 square, which is 1 by 4. 2 power n minus 2 means 2 power n divided by 2 square. I can write that as 2 power n into 1 by 4. Okay. So now, in this case, I will take 3 power n as a common factor. If I take 3 power n as common, you have 3 here, plus here you will have 2 by 3 whole power n into 4. Okay, divide by. Similarly, I will take 3 power n common here also. 1 by 3 plus 2 by 3 whole power n into 1 by 4. Okay, so now this 3 power n gets cancelled. Now as n tends to infinity, 2 by 3 whole power n, as this fraction 2 by 3 is less than 1. So this as it tends to infinity, as the power n tends to infinity, as the power tends to infinity, this fraction being less than 1 will become 0. So we get 3 plus 0, 0 into 4, that is 0, divided by 1 by 3 plus 0. So that's equal to 3 divided by 1 by 3. Hence, the answer is 9. 9, which is the third option. Okay. Next question. Limit x tends to infinity, x plus 1 to the power 10 plus x plus 2 to the power 10, etc. till x plus 100 to the power 10 divided by x power 10 plus 10 power 10 is equal. Okay. So x plus 1 whole power 10. In general, I'll explain binomial theorem, which is actually it was reduced in, it is there in first PSA, but it was in the reduced syllabus last year. So binomial theorem. Have you heard of this theorem, binomial theorem? Did you learn this during first PO? Binomial theorem. Okay, some of them saying yes, some of you are saying no. Okay. Heard but not learned. Okay, no. Okay, anyway, I will explain. I will explain binomial theorem. Okay, so what it tells you is if n is a positive integer, then x plus a whole power n, is equal to nc naught x power n into a power 0 plus nc1 into x to the power n minus 1 into a to the power 1 plus nc2 x to the power n minus 2 into a square and so on till ncn x power 0 into a power n. Okay, for example, if I take x plus a whole square, here n is 2, go on substituting, 2c naught x square a power 0 plus 2c1 x to the power n minus 1, 2 minus 1, that is 1, into a power 1 plus 2c2 x to the power 0 into a square. That's all. You have to stop at ncn. So here we should stop at 2c2. 2c0 is 1, x square, a power 0 is also 1. So this will be x square plus 2c1 is 2 into x into a. So 2ax plus 2c2 is 1, x power 0 is 1, a square. X square plus 2ax plus a square, which is the expansion of x plus a whole square, right? So that can be explained during binomial theorem also. And if you want, I'll take one more. X plus a whole power 3, that's equal to 3c naught x cube a power 0 plus 3c1 x power n minus 1, 3 minus 1, which means x square into a power 1 plus nc2 means 3c2 x to the power 1, 3 minus 2 is 1 into a square plus 3c3 x power 0 n minus 3, that is 0, into a power 3. Okay, so now this is equal to, if you simplify, 3c0 is 1, that is x cube, 3c1 is 3, 3ax square, 3c2 is also 3, 3a square x plus a cube. This is what you are going to get if you expand x plus a whole cube by using that formula, a plus b whole cube. By using a plus b whole cube, if you expand this, what are we going to get? A cube plus b cube plus 3ab into a plus b. So this on simplification will give you x cube plus a cube plus 3ax square plus 3a square x. Okay, so same thing you have. Okay, so the reason why I have explained all these things here, actually we don't need to use binomial theorem here in this problem, but still I explained this only because just to tell you that in the expansion of x plus a whole power n, the number of terms, you just observe x plus a whole square, in this the number of terms in the expansion is 3. In case of x plus a whole cube, the number of terms in this expansion is 4. So in the expansion of x plus a whole power n, the number of terms will be n plus 1. The number of terms will be n plus 1 because you just observe starting with nc0. First term contains nc0, then nc1, nc2, nc3, etc. till ncn. Okay, so starting with nc0, nc0, nc1, nc2, nc3 up to ncn. So there are n plus 1 terms in this expansion. Okay, so now coming to this problem. Here, if you consider only x plus 1 whole power 10, if you expand it, you are going to get 11 terms. I'm not interested in all those 11 terms. I'm just interested in knowing what is the degree of this polynomial. So x plus 1 whole power 10, its expansion would be like this: 10c naught x power 10 into 1 power 0 plus 10c1 into x power 9 into 1 power 1, etc. See, I'm interested in knowing what is the highest power of x. In this expansion, in the expansion of x plus a whole square, the highest power of x is 2. In the expansion of x plus a whole cube, the highest power of x is 3. In the expansion of x plus a whole power n, the highest power of x is n. You just observe, first term contains x power n, next x power n minus 1, then x power n minus 2, x power n minus 3, and so on till x power 0. So the power of x goes on decreasing and it reaches 0. Okay. So every term it is decreasing by 1. So therefore, the expansion of x plus 1 whole power 10 is a polynomial of degree 10. That is the only thing that I want from this. Okay. So is it clear that this x plus 1 whole power 10, when you expand it, you are going to get a polynomial of degree 10 and the coefficient of x power 10, 10 C0 is 1 into 1. That is 1 into x power 10 plus something. So when you expand x plus 1 whole power 10, you are going to get a polynomial of degree 10 where the coefficient of x power 10 is 1. Did you understand this step? This sentence? In the expansion of x plus 1 whole power 10, when you expand it, you are going to get a polynomial of degree 10 where the coefficient of x power 10 is 1. Okay, all of you understood? Okay, fine. Then now you look at x plus 2 whole power 10. When I expand this, you are going to get like this 10 C0 x to the power 10 2 power 0 plus 10 C1 x to the power 9 2 power 1 and so on. So here also you observe coefficient of x power 10 is 1. 10 C0 is 1, 2 power 0 is also 1. So this is also a polynomial of degree 10. And the coefficient of x power 10 is 1. In the same way, each of these, so after this you have x plus 3 whole power 10, then x plus 4 whole power 10, x plus 5 whole power 10, etc. till x plus 100 whole power 10. Each of these terms, so when you expand, they become polynomials of degree 10. Okay. So now I will write like this: limit x tends to infinity, x to the power 10 plus something. This is the expansion of x plus 1 whole power 10. Then if you expand x plus 2 whole power 10, there you will get x power 10 plus something. Okay. Plus. Then when you expand x plus 3 whole power 10, there also you are going to get x power 10 plus some numbers and so on. You get it. Finally, last term if you expand, last term is what? X plus 100 whole power 10. When you expand this, it will look like this: 10 C0 x power 10 a power 0. When a means in this case 100 plus 10 C1 x power 9 into 100 and so on. So there also it is a polynomial of degree 10 and the coefficient of x power 10 is 1. There are 100 such expansions. First expansion is x plus 1, then x plus 2, x plus 3 and so on till x plus 100. So each of these is a polynomial of degree 10 and the coefficient of x power 10 is 1 divided by x power 10 plus 10 power 10. That's equal to limit x tends to infinity. So there are 100 such expansions. So if I add all those, I'm going to get 100 into x power 10 plus some number into x power 9 plus some other number into x power 8 and so on. Denominator is x power 10 plus 10 power 10. Now you observe the numerator is a polynomial of degree 10. The denominator is also a polynomial of degree 10. When both are polynomials of the same degree and when x tends to infinity, the value of this limit will be equal to the coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator. So in the numerator, the coefficient of highest power of x is 10. Therefore, I am only interested in knowing what is the x power 10 terms. Only I'm looking at them, not at x power 9, x power 8, etc. They are irrelevant now because it is a polynomial of degree 10. When both are polynomials of the same degree, then the value of that limit is equal to coefficient of highest power of x in the numerator divided by coefficient of highest power of x in the denominator. In the numerator it is 100, in the denominator it is 1. So the answer is 100. 100. Is it clear to you? Yes, sir. Okay. Fine. Not understood. Look at x plus 1 whole power 10. Expand it. When you expand, you are going to get, okay, I will explain once again. Please listen. It require more time. Okay, one student is asking require more time. Why it requires more time now? It is because I am going very slowly. Even though some of you feel that it is faster, this is much slower. Okay. So while I'm explaining very slowly, so it takes more time. Otherwise, you can solve this within 1 minute, not a problem. Okay. Anyway, I'll explain once again. Just observe. X plus 1 whole power 10. Its expansion is 10c0 x power 10 into 1 power 0 plus 10c1 into x power 9 into 1 power 1, etc. Then x plus 2 whole power 10. Okay, by that you know that x plus 1 whole power 10 is a polynomial of degree 10 and the coefficient of x power 10 is 1. Then look at the second term, x plus 2 whole power 10. X plus 2 whole power 10 is another polynomial. Its expansion is 10c0 x power 10 into 2 power 0 plus 10c1 into x power 9 into 2 power 1 plus 10c2 into x power 8 into 2 square and so on. So when you expand each of those, there are 100 terms. Okay, 100 expansions here, and each expansion contains 11 terms. Okay, x plus 1, x plus 2, x plus 3 up to x plus 100. So there are 100 terms there. And when you expand them, x plus 1 whole power 10, its expansion will contain 11 terms. X plus 2 whole power 10, its expansion will also contain 11 terms, and so on. Okay, so x plus 100 whole power 10, its value, each of these is a polynomial of degree 10, and the coefficient of x power 10 in each of these terms is 1. So that 1 plus 1 plus 1, 100 times here. See, from this expansion, you'll get x power 10 once, here once, here once. So add all those 1 plus 1 plus 1, x power 10 plus x power 10 plus x power 10 plus x power 10, 100 times will give you 100 x power 10 plus, and some more terms are there, which we are not interested in. So now both are polynomials of the same degree, x power 10. Hence, when x tends to infinity, the value of this fraction, this expression is equal to coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator. So here it is 100, here it is 1. So the answer is 100 by 1. Okay. So one student is asking, sir, how do we get to know that 100 C0 is equal to 1? Okay. For that, you know this formula NCR. NCR. This is equal to n factorial divided by n minus r factorial into r factorial. So 100 C0 is equal to 100 factorial divided by 100 minus 0. Means 100 factorial into 0 factorial. 100 factorial gets cancelled. 0 factorial is 1. 1 by 1 is equal to 1. Sir, can we assume that x plus 1 as y and then simplify? No, because it will not take you anywhere. Look here, if you treat this as y, then this is y power 10. Then this will become x plus 1 plus 1. This will become y plus 1 whole power 10, etc. Y plus 199 whole power 10. By this, you don't achieve anything. So, not advisable. Don't do that. Let's go to the next question. Limit extends to infinity. 2 plus x whole power 40 into 4 plus x whole power 5 divided by 2 minus x whole power 45. Okay. So before this, I have explained you what is the expansion of x plus a whole power n, right? This is equal to nc naught x power n a power 0 plus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 into a square and so on till ncn x power 0 a power n, right? So now from this I will explain what is x minus a whole power n. In this, wherever there is a, replace it by minus a. We have x minus a whole power n, right? So nc naught x power n minus a whole power 0 plus nc1 x power n minus 1 into minus a whole power 1 plus nc2 x power n minus 2 into minus a whole square and so on. nc n x power 0 minus a whole power n minus a whole power n. Okay, this is what we have now. Now, okay, further let me simplify. nc naught minus a whole power 0, that is 1 only, x power n. Here minus a whole power n, it will be, I can write this as minus nc1 x power n minus 1 into a. Minus a whole square, it will be plus only. nc2 x power n minus 2 into a square. Next term will be minus a whole cube, so it will become minus nc3 x power n minus 3 a cube plus nc4 and so on. Here I can write this as minus 1 to the power n into ncn x power 0 a power n. Okay. So if n is even, this last term will be positive. If n is odd, this last term will be negative. Okay. So in this problem, let me write the expansion of all these. 2 plus x whole power 40. Let me expand this. This will be equal to 40c naught. In place of x, we have 2 here. In place of a, we have x here. So I'll write like this: 2 power 40 into x power 0 plus 40c1 2 power 39 into x power 1 plus 40c2 2 power 38 into x square, etc. Last term will be 40c40 2 to the power 0 into x power 40. Okay. Look at the next term now. What is the next term? 4 plus x whole power 5. 4 plus x whole power 5. 4 plus x whole power 5 is equal to 5c naught 4 power 5 x to the power 0 plus 5c1 4 to the power 4 into x to the power 1 plus 5c2 4 cube x square plus etc. Last term will be 5c5 4 power 0 into x power 5. Okay. So you just observe that numerator is a polynomial. This first term, first expansion is a polynomial of degree 40. So I can write like this: 2 plus x whole power 40 is equal to 40c40. ncn is also equal to 1. 40c40 is equal to 40 factorial divided by 40 minus 40, that is 0 factorial, into 40 factorial. 40 factorial gets cancelled. 1 by 0 factorial is 1. So this will give you 1. So 2 plus x whole power 40 is 2 power 0 is also 1. It is equal to x power 40 plus x power 39. Previous term there will be x power 39 into some number plus x power 38 into some number, right? Etc. Similarly, 4 plus x whole power 5. It is a polynomial of degree 5. I can write this as x power 5 plus x power 4 into some number plus x cube into some number, etc. This first expansion, first term is a polynomial of degree 40. Second term is a polynomial of degree 5. Now, if I multiply them, say first term with the first term, if I multiply x power 45, then x power 40 into x power 4 will give you x power 44. X power 40 into x cube will give you x power 43, and so on. So this product is there now. 2 plus x whole power 40 into 4 plus x whole power 5 is equal to x power 45 plus some number into x power 44. Here x power 40 into x power 4 gives you x power 44. X power 39 into x power 5 will also give you x power 44. Add them, simplify. So x power 44 into some number, etc. Similarly, some number into x power 43, etc. So from this we can conclude that this product is a polynomial of degree 45 and the coefficient of x power 45 is 1. Now coming to denominator. Where is the denominator? 2 minus x whole power 45. 2 minus x whole power 45. That is equal to n c naught x power n. N c naught means 45 c naught x power n 2 power n minus n c1 45 c1 2 power n minus 1 into x plus n c2. What is n here? 45. 45 c2. X means 2 here. 2 power 43. What is n? That also right. N is 45 here. 2 power 45. This will give you 2 power 44. Here 2 power 43 into x square minus plus etc. Look at the last term. Minus 1 whole power n. Here whole power 45. That will give you minus NCN 45 C 45. X power 0 means 2 power 0. A power n x to the power 45. Okay. So now observe that this is a polynomial of degree 45. I will write here. This for 2 power 0 is 1. 45 C 45 is 1. We get minus x power 45 plus some number into x power 44 plus some more number into x power 43 and so on. Okay. So from this, now I will write like this. Given problem, I will write it in this way. So what they have given, limit extends to infinity 2 plus x whole power 40 into 4 plus x whole power 5 divided by 2 minus x whole power 45. So this is equal to limit extends to infinity. So this product we have got x power 45 plus some number into x power 44 plus some other number into x power 43 and so on. Denominator, here we have got denominator is minus x power 45 plus some number into x power 44 plus some more number into x power 43 and so on. Numerator is a polynomial of degree 1 and degree 45. Denominator is also a polynomial of degree 45. So both are polynomials of the same degree. Therefore, the answer is coefficient of highest power of x, which is 1 in the numerator, divided by the coefficient of highest power of x in the denominator, which is minus 1. So the answer is minus 1. Okay, did you understand this problem? The solution? See, when I had explained all these things, you might feel it is somewhat complicated. But you just observe here, 2 plus x whole power 40, the highest power of x will be 40. And because you have plus here, its expansion, it's a polynomial of degree 40, x power 40. Then look at this. Here also you have plus in between. So this is a polynomial of degree x power 5. And the coefficient of x is 1 here. If it is 2 here, then it will be 2 power 5. That 32 x power 5 would be the coefficient. Okay. So now coefficient of x power 5 is 1. When we multiply, this first one is a polynomial of degree 40. Second one is a polynomial of degree 5. So when we multiply, we get another polynomial of degree 45. and the coefficient, here it is 1, here it is 1. So 1 is the product also of 1. And look at this. This is a polynomial of degree 45. And because of the presence of minus here, the coefficient will be minus 1 to the power 45. Since you have odd number here, we get minus 1. Suppose instead of 45, if it is 46, so then it would have been plus 1, the coefficient of x power 46. Okay. So now numerator is a polynomial of degree 45. Denominator is also a polynomial of degree 45. And coefficient of x power 45 in the numerator is 1. And in the denominator, it is minus 1. Okay. Minus 1. So the answer is minus 1. Just by observing this, you can write. Just for making you understand, I have written all these terms. I need not write all these terms. You will not have that much space either. So directly by looking at this only, need not write the first term again. So directly you write the answer. Okay, as 1 by minus 1, you'll get the answer as minus 1. Okay. So now suppose instead of this, okay, another good question here. Suppose if you have say 2 plus x whole power 40 into 4 plus 2x whole power 5 divided by 2 minus x whole power 45. If this is the case, what would have been the answer? Here coefficient of x is 1, 1 power 40, 1. Here coefficient of x is 2, 2 power 5. Here denominator coefficient of x is minus 1 to the power 45. Okay. So 1 power 40 is right. 2 power 5. Okay. So 1 power 40 is 1, 2 power 5 is 32, denominator is minus 1, then the answer would have been minus 32. It is as simple as this. Okay, this is a shortcut. Directly by looking at it, you can write in this way. But one thing you have to ensure that the power here 40 plus 5, power will be 45, here also 45. Coefficient power must be same. If the powers are different, you cannot use this. Power, if the numerator has a larger power, then the answer is infinity. If the denominator has a larger power, then the answer is 0. Is it clear? Okay. Then look at the next question, 64th. Limit extends to infinity, x plus sin x divided by x plus cos x. Limit extends to infinity, x plus sin x divided by x plus cos x. Okay, as it is, if I apply the limit, you are going to get infinity by infinity, which is an indeterminate form. So I will divide by x, divide both the numerator and denominator by x. That will give you 1 plus sin x by x divided by 1 plus cos x by x. Okay, so that is equal to 1 plus, when x tends to infinity, sin x by x becomes 0, divided by cos x by x also becomes 0. So the answer is 1. Okay, so I have explained this already. Limit extends to infinity, sin x by x will be equal to 0. Why it is 0? Because I can write this as, I can split this as limit extends to infinity 1 by x into limit extends to infinity sin x. So limit extends to infinity 1 by x, this will become 0. This will be equal to 0. And this limit extends to infinity sin x will be a finite number between minus 1 and 1. So 0 into that finite quantity, that product will become 0. And similarly, limit extends to infinity cos x by x is also equal to 0. So on simplification, we get the answer as 1. Okay, then. No. Can we directly say that it is both are linear equation? No, there is a sin x also. It is not a linear, it is not a polynomial. That formula we can use only if it is a polynomial. Here's one question. Can we directly say that it is 1 because it is a linear equation? No, you cannot. Okay. So it's not a linear equation since sin x is also there. Limit extends to infinity 5 power x into sin a by 5 power x is equal to. Limit extends to infinity 5 power x into sin a by 5 power x. That's equal to limit extends to infinity. I'll write like this, sin of a by 5 power x. I'll take it to denominator. This will become 1 by 5 power x. I need a by 5 power x. I'll multiply and divide by a. Now, as extends to infinity, listen to this very carefully. as x tends to infinity, 5 power x will also tend to infinity. 5 power x tends to infinity, then 1 by 5 power x tends to 0. It is a reciprocal of 5 power x. When x tends to infinity, 5 power x tends to infinity, its reciprocal 1 by 5 power x will tend to 0. So 1 by 5 power x tends to 0 means a by 5 power x also tends to 0. A by 5 power x tends to 0. So this is like as good as limit theta tends to 0 sine theta by theta. So this expression will be equal to 1 into A is equal to A. Note the difference between the previous problem and this problem. In the previous problem, I told you that limit x tends to infinity. See, earlier I told you limit x tends to infinity, sine x by x is equal to 0. It is true. Now I am saying that limit x tends to infinity, sine 1 by x divided by 1 by x. This is equal to 1 because when x approaches infinity, 1 by x will approach 0. So therefore, here in this question, when x tends to infinity, 5 power x also tend to infinity. Hence, 1 by 5 power x will tend to 0. And therefore, a by 5 power x also will tend to 0. Hence, this much will be equal to this much will be equal to 1. So the answer is 1 into a, which is equal to a. Second option. Okay. Then 69th question. Limit n tends to infinity 2 power 3n divided by 3 power 2n. So 2 power 3n can be written as 2 cube whole power n divided by this can be written as 3 square whole power n, which is equal to limit n tends to infinity 2 cube, that is 8 power n divided by 3 square, which is 9 power n. So that's equal to limit n tends to infinity 8 by 9 whole power n. 8 by 9 whole power n. Observe 8 by 9 is a fraction which is less than 1. So power tends to infinity. Therefore, the value of this expression, this limit, will be equal to 0. Okay, 0, which means first option is the right answer. Limit x tends to infinity. Next question, question number 70. Okay, concentrate here. Many of you are leaving the meeting, maybe because you are not understanding my teaching. I don't know, but anyway, just attend and just concentrate. Okay, so see, success. You will gain success only when you don't give up anything. If you give up anything in the middle, say assume that you are running a race for 400 meters or so. So even if you are first for the first 300 meters, okay, then if you give up in the last round, then you don't get any medal, right? So you just concentrate. Soon after this problem, I'll leave you. Don't worry. Okay. So limit x tends to infinity x cube by 2x square minus 1 minus x square by 2x plus 1. If you directly apply the limit here, you just concentrate on this term. X cube by 2x square minus 1. This is a polynomial. Numerator is a polynomial of degree 3 and denominator is a polynomial of degree 2. So numerator has a larger power. When the numerator has a larger power, the value of this expression will be infinity. And look at this, x square by 2x plus 1. Again, here also, numerator is a polynomial of degree 2 and denominator is a polynomial of degree 1. So this will also give you infinity. Infinity minus infinity. Infinity minus infinity, don't think that I can cancel infinity. Okay, so we are not that good to cancel that infinity. Infinity cannot be cancelled, right? Infinity minus infinity, don't write that as 0. It is not. Infinity minus infinity is an indeterminate form. Okay, so for this you cannot use L'Hospital's rule. No, L'Hospital's rule can be used only if it is of the form 0 by 0 or infinity by infinity. Now we are talking about infinity minus infinity, so L'Hospital's rule cannot be used. Then what else can I do? Can you see any common factor here? Wait, I'll clean this so that you can see some common factors. Yes, you can. Okay, so x square is a common factor here. So that x square I will take out. Then what will remain here? X divided by 2x square minus 1. Minus, here I have taken x square out. So 1 by 2x plus 1. That's equal to limit x tends to infinity, x square into this product 2x square minus 1 into 2x plus 1. This numerator will be x into 2x plus 1, x into 2x plus 1 minus 1 into 2x square minus 1. Okay, so that's equal to limit x tends to infinity, x square into x into 2x, that will give you 2x square plus x minus 2x square plus 1 divided by, if you multiply this, here you are going to get 4x square plus 2x square minus 2x minus 1. 2x square gets cancelled. Limit x tends to infinity, x square into x plus 1. Okay, sorry. Here 4x cube. 2x square into 2x. I made that mistake. So 2x square into 2x will give you 4x cube, then 2x square minus 2x minus 1. Okay. So x square into x plus 1 in the numerator. Denominator contains 4x cube plus 2x square minus 2x minus 1. Okay. So that's equal to limit x tends to infinity. Take this x square inside. You get x cube plus x square divided by 4x cube plus 2x square minus 2x minus 1. Numerator is a polynomial of degree 3. Denominator is also a polynomial of degree 3. Both are polynomials of the same degree. Then the value of this limit is equal to coefficient of highest power of x. Highest power of x is 3 here. X cube is the highest power. So its coefficient is 1 in the numerator, 4 in the denominator. Hence the answer is 1 by 4. 1 by 4, which is the fourth option. Okay, students, with this I will stop today's class. All the problems which I have left in between, that will be the assignment for you. Okay. So further, if you have any doubts, you can ask me. If you have any doubts, please ask me, or those who do not have any doubt can leave the meeting. Okay, so 54th question, Rashmi has a doubt. Question number 54, where is 54? Okay, so very simple. A screenshot I will send, that PDF, and I will send it, don't worry. Okay, so 54th question, limit extends to a log x minus log a divided by tan x minus a. If I directly apply the limit, we are going to get a log a minus log a. Log a minus log a is 0 divided by tan a minus a, you get tan 0, that is 0. 0 by 0 is an indeterminate form, so I am using L'Hospital's rule. Derivative of log x is 1 by x minus the derivative of log a. Log a is a constant, a is a constant, and therefore if log a is also a constant, its derivative is 0. Divided by tan x minus a is there, whose derivative is secant square x minus a. Now apply the limit as x tends to a. So you get 1 by a divided by, putting x equal to a here, a minus a is 0. Secant square 0 is 1. So the answer is 1 by a. Okay. Next doubt is from Deepak. Sir, answer my above asked question. What is your above asked question? I don't know, Deepak. What is the value of infinity to the power 3 or any number? It is infinity only. Okay, infinity cube, infinity square, all these are equal to infinity only. Okay, 69th you need a screenshot of Umar Farooq. Don't worry, I will send. 56th question you have a doubt. Okay, so limit extends to 0 log 1 plus x divided by 3 power x minus 1. If you directly apply the limit, put x as 0, numerator will give you log 1 and denominator is 3 power 0, 1 minus 1. The log 1 is 0, 1 minus 1 is 0. 0 by 0, it is an indeterminate form. When it's an indeterminate form of the type 0 by 0 or infinity by infinity, we can use L'Hospital's rule. By using L'Hospital's rule, derivative of log 1 plus x is 1 by 1 plus x And the derivative of 3 power x minus 1 is 3 power x into log 3. Put x equal to 0. So 1 by 1 will give you 1. Here 3 power 0 is 1 log 3 to the base e. Base is not mentioned, means base must be e. Log 3 to the base e can be written as 1 by log e to the base 3. How? Say, if you have any doubt, I'll write like this. 1 can be written as log e to the base e divided by log 3 to the base e. So log e to the base e by log 3 to the base e is equal to log e to the base 3. By using that change of base rule, we can write it in this way. Or you know this also, log a to the base b is equal to 1 by log b to the base a. Okay, what is the next doubt? Will you send recorded lectures in YouTube also? Not same only this week or few days we are doing because of floods. Many of the students are not able to attend live classes. Hence, to ensure that they don't miss the class, we will record the videos and send only for the next 3-4 days. Okay. Why don't we send every day? Is because if we do that, then you stop watching live classes. Then there is no point in attending. Then there is no difference between YouTube and Zoom class. So just to ensure that you attend all the classes regularly, we don't record and we don't send in general. However, when there is a genuine problem like this, we will send. Okay, Nidhi has another doubt. Sir, please once again, how it is equal to 1 by 4 in last problem, last step. Last problem, last step. Where is the last problem? Last problem. Okay, here, 1 by 4. See, couple of days ago, I had told you that when you have limit extends to infinity, f of x by g of x, both are polynomials of the same degree. Okay, let us say f of x is a polynomial of degree m, g of x is a polynomial of degree n. Now, if m is equal to n, then this limit is equal to coefficient of x power m in the numerator divided by coefficient of x power n in denominator is the answer. When they are polynomials of the same degree, if they are of different degree, then we can't use this formula. If they are of the same degree, then the answer is equal to coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator. In the numerator, there is x cubed plus x square. It is a polynomial of degree 3. Denominator consists of 4x cubed plus 2x square minus 2x minus 1. It is also a polynomial of degree 3. Now both are polynomials of the same degree. Then as x tends to infinity, the value of this limit is equal to coefficient of x cubed in the numerator, which is 1, divided by coefficient of x cubed in the denominator, which is 4. So the answer is 1 by 4. 66, you heard out. 66. Okay. Limit extends to infinity 5 power x by into sine a by 5 power x. This 5 power x I am taking into denominator. It will become a by 5 power x. You all know that limit theta tends to 0, sine theta by theta is equal to 1. I am using this formula here. Now you might be thinking, sir, x is tending to infinity. Yes, true, x is tending to infinity. But when x is tending to infinity, 5 power x will also tend to infinity. But 1 by 5 power x being its reciprocal, the reciprocal of infinity is 0. 1 by 0 is infinity, right? 1 by 0 tends to infinity. Therefore, 1 by infinity tends to 0. So when x tends to infinity, a by 5 power x will tend to 0. So it's of the form sine theta by theta. That's equal to 1 as theta tends to 0. Into that a was missing. So multiplied and divided by a. 1 into a. We got the answer as a. 50th question. Vineet has a doubt in question number 50. Where is 50? 50 is not here only. Okay, so you post that in yesterday's assignment solutions, madam has sent it. So it must be there. Just check. If it is not there, please ask that same question again in our WhatsApp groups. Okay, sir, send PDF in group. Yes, sure, I will send it. This live session can be uploaded in YouTube to see it again. Yes, I will upload. As I said, only for few days till the the flood goes out. Okay, till it becomes normal, we will send. Once it is normal, we will not send. 66th question, I think I have answered again. Last question, last step I have answered. 61st question from Nandesh. Okay. 3 power n plus 1. 3 power n plus 1 can be written as 3 power n into 3. 2 power n plus 2 can be written as 2 power n into 2 square. 2 square is 4. Denominator 3 power n minus 1 is there. It is nothing but 3 power n divided by 3. And 2 power n minus 2 is 2 power n divided by 2 square. 2 square is 4. So numerator I am taking 3 power n as common. Here 3 power n, if I take out, 3 will remain. Here 2 power n by 3 power n will remain. That can be written as 2 by 3 whole power n into 4. Similarly, in the denominator also I am taking 3 power n out. Here 1 by 3 will remain. Plus here 2 power n by 3 power n, which can be written as 2 by 3 whole power n into 1 by 4 is remaining. So this 2 by 3, it is a fraction which is less than 1. When that fraction is less than 1 and the power tends to infinity, the value of that fraction becomes 0. So as n tends to infinity, 2 by 3 whole power n becomes 0. So 3 plus 0 into 4, that is 0. Here 1 by 3 plus 0 into 4, 1 by 4 is 0. 3 by 1 by 3, that's equal to 9. 56th question, differentiation of denominator. 3 power x, derivative of a power x is a power x into log a. So derivative of 3 power x is 3 power x into log 3. Minus 1 is a constant, so its derivative is 0. Infinity power 3 or any number, what is its value? Infinity cube, it is 0, 0, 0. Sorry, infinity only. Infinity to the power any number is infinity. Is it applicable only when x tends to infinity? Which one? F of x by g of x. Yes. It is applicable only when x tends to infinity. 61. Just now I have explained. That should be enough. Deepak, okay. So infinity to the power 3 or any number, what is its value? It is infinity only. How many times you are asking the same question again? Okay, fine. Denominator 1 by 3. How, sir? Denominator 3 power n by 2, n minus 2 is there now. This can be written as 3 power n by 3, n minus 2 or n minus 1. What they was given? N minus 1 there. Okay. So 3 power n minus 1 is equal to 3 power n by 3 power 1. This is equal to 3 power n into 1 by 3. In that 3 power n I have taken out, so 1 by 3 is remaining. Okay, that's all I think. Any other doubts? Students, any more doubts do you have? Okay, that's all I think. Okay, students, with this I will stop today's class. Thank you.